But this is even getting further exciting as to the topic of the panel. And it's pretty difficult to get this kind of group together. So we'll take advantage of the opportunity. So I think we're about 45 minutes behind. If we take the strategy Tim adopted, we perhaps only have. So I think we'll manage to do this maybe. We'll try to do this maybe between 50 minutes to an hour. And very quickly, Mike was on the stage earlier today, so no need to introduce. If I apologize for just going through this very quickly. Tapani as well. Carol Song, Purdue University computer scientist, cyber infrastructure expert on the campus there. Lynn, no need to introduce, was speaking yesterday. And A-Xing at University of Wisconsin-Madison, but he's also holding distinguished professorship with Chinese Academy of Sciences and Nanjing Normal University, so he will also help bring some international perspectives to this discussion. So we have a really distinguished group of panelists. The questions I shared with them through email. You did not get it? Oh. How many of you did not get it?
I got it.
Okay, yeah, all right. Well, they're not very complicated questions. Answers may be complicated. So if you have slides, let's go with this plan. If you have slides, who has slides? A-Xing has slides? Okay, so you're the only one. Maybe we'll go with you, A-Xing, first. We have each of the panelists to start with some opening remarks. That will take for each of them maybe 3 to 5 minutes. And then we'll go directly to open discussions. A-Xing. Yeah. Oh, okay.
Yeah. Better probably just stand there. That's okay. Yeah, I'll stand here. You don't want me to control that? Yeah. Well, just to start, it's actually, since Shaowen posted a question which is wide open for future, and I don't know if any of us can predict what the future will be. So what I'm going to talk about is some inspiration from a simple instance that I experienced a few years ago, a couple years ago actually. I was one of the crazy guys trying to get a ringtone on an iPhone, and then I have a movie format. I want to convert it into MP3, which iPhone only took. So, and then I asked one guy. He said that, well, you can take the HP the link, paste it into that box, then you get an MP3. Well, with an old guy like me, I will often ask how they do it, and the guy responded, say, "Why do you want to know? You get what you want." So that led me to believe one of the things that probably we geographers should think about. So, because when we drive a car, we'll never really figure out how the mechanics in there. And do we need to, so the question is that, do we need to continue to really know everything to do it? Can we box certain things and give it to the public to do it? So this is leading to the question. So how probably got to go forward, isn't it? This is the question. So what I propose is the future direction will be one of the things called EasyGC. So the easy geographic computing. And really, easy does not mean simple. Easy means a convenient, be able to do it correctly in a convenient way. Last couple of days, we have heard a lot about geodesign. I think one of the things probably we allow easy interface, integration of computation technology or geographic computation technology into the geodesign firm. So from this perspective, there are 4 characteristics of this particular EasyGC. The first one should be problem-driven. So basically, user goal-driven is not task-oriented or procedure-oriented. It's actually goal-oriented. So what you want to achieve, rather than how you're going to do this thing. The second one has to be intelligent. So not only knows the sequence of procedures, but also knows the appropriate algorithm, the parameter to choose given a user goal. So this is something really smart. The third one has to be fast computing, which I've seen a lot of that, so I'm not going to get into. The fourth one is you can share with anybody the things. Easy to share. You don't have to know the technology to share, but you just can share. So that's the really fourth one. So the premises for this particular thing is that we want the general public to be able to do geographic computing. So if that's true, then what I'm saying may have some validity. If it's not true, then what I'm saying is just probably a joke. So we'll see that part. So basically, let's look at, if it's true, then look at the number of users versus the level of skill. This is a schematic diagram. So one level is the level of skill of GIS computing technology, ability to do computing. The horizontal axis will do the number of people that might be able to do it. So look, this is a diagram. So we are here, the geographic computing expert, very few. So then the next group would be the experts in other fields, right? They do use GC to do what they want to do. The really big one you make a lot of money out of is the general public. So anything you get the general public to buy in, you get a big use. So they actually use GC services. So I'm just going quickly because time is short. So the current system, we have some troubles with that. The first one is kind of a data computation intensive and computation intensive. Some people even say parameter intensive. So really is slow computation. The other one is too much domain knowledge that I have to earn another PhD to do this geographic computing. That preventing people to go that direction. The other one is, the third one is procedure-oriented rather than task-oriented. Say, I want to do this, but I do not know how to do it. So you have to learn how to do it, the steps that we created for them. Finally, there's too many hurdles to share. So the existing system, ArcGIS, certainly, or certainly one of the popular ones, and certainly some other system coming up, the Supermap in China, and some other modeling software like SWOT and so on and so forth. They are targeted towards the expert. Really, you know how to do things, and you know the discipline, and know that have the knowledge. And it's not so much towards the other expert, the public. So on the other hand, most of the system, well, not quite correct, but still using a single core, and we do have a high-performance computing facility available. So to summarize, this is we're facing two digital divides. One is the user divide, so the experts versus general public. The other one, computational divide, which is the single core versus the hard one, the multiple core and high-performance computing stuff. So what we getting into it is we doing the second one, the computational divide, very well in CyberGIS. We should have overcome a lot of hurdles and bring up. The one we haven't done as much as we should do to bring that to the public is the user divide. So that would be the premises and the reason why that we want to do. So the things here is easy. So basically easy to use, easy to compute, easy to use. You need to develop a set of the red boxes, the intuitive, assisted, cyber-enabled kind of system that allow the intelligent. So and intelligent model building. The other one easy to compute, which basically high performance enabled, complex geographic computing that enabled. So that would be the high performance computing in a platform. That'll give you some sort of a easy geographic computer platform. So that would be the thing that I think in the future we need to look at if that is we want to bring that to the general public to use the skill the technology, the knowledge that we've earned. So what's the reason for that? I think there are two ways for doing this future challenge. One is we have the new way of formulating our geographic knowledge and geographic computing. Currently, this way probably need to restructure it. The second one is that we have the new set of methods that have little statistical constraints. I'm provoking people to remove the statistical constraint. But it is true that the VGI data set, that does not follow the traditional statistics method. So that would be. So what's the major frontier? Which the questions that basically say the general public are concerned over our living environment. They want to be part of that process. They want a part of that decision process. They just don't want to be told. So being able to be part of that, they'll be able to do geographic computing. So that would be the way I'm talking about. The other two questions, I think I answered 5 out of 6, 3 out of 5, so I'll get 60 points. So if I get all correct. So I'll stop here. Thank you.
All right. Tapani, do you mind to do the next? Thank you.
Thanks. I think that is it done? Okay. So much has been said that I don't really have too much to add, but I have one question that if you think that you would have a computing environment where you would have infinite computing power and infinite memory and infinite connectivity, what would you do? In a way, in a cyber infrastructure, we are approaching step by step that kind of situation, that we have more and more everything. And to me, the one answer is that we still have the problem of the modeling. How do we formulate our things? We don't have to think that much about the implementation, or we shouldn't, but only trust that we have the computing power, everything. That's one loose thought about things. And another loose thinking is that in one paper I read that it's very typical for any infrastructures that they are messy, because the infrastructures are something that evolve. We don't just build them in one day, but they evolve. If you think about the electrical systems or road networks, water systems, all of them are very, very messy. You don't know how they really work. And I would argue that in a cyber infrastructure, we have the same problem. They are messy. They must be messy. And the question is that how can we handle with this messiness? To some extent, we want to take the advantage of that, but to the other end, we have to make some systematization all the time. That's, I think, I don't have more to offer to you. Thanks.
Maybe go to Karen, since Matthew did not see the question, we'll leave you to the last.
Oh,
yeah.
I'll take the last question.
Fingerprint recognition work. Well, first of all, maybe I should say a few words about why I'm here, and because I think most of you probably don't know me. I'm a computer scientist, and I got my degree from UIUC, so I do have connections to Shaowen. The way I got into geospatial data analysis and modeling and making that available to broad audiences is actually through high-performance computing. I was very involved with TerraGrid and now Exceed. Nancy Wilkensteer here is my good colleague in those projects. And as Nancy also initiated the Science Gateway initiative within TerraGrid, and back several years ago, as we built more science gateways, which tend to be portals and making scientific tools available to people, we found that we have requests from people to create geospatial enabled applications and modeling tools and so on. And as we built more and more of these, and we thought, gee, we should make these more generic and make tools more easily, make it easy for people to create tools and deploy them into the web, because that's what everybody wants to do these days. As Amy from NSF mentioned, so I feel obligated to say a few words about our DIPS award. So it's one of the Data Infrastructure Building Blocks Award. We're in year 1, and trying to integrate geospatial data analysis and modeling capabilities into the core Hub0 infrastructure. For those of you who have never heard about it, Hub0 is an open source platform for creating dynamic websites for scientific collaborations. So in addition to the ability of hosting self-published tools and self-contributed content, it provides a lot of the scientific collaboration capabilities. And if you have questions, I'd be happy to answer. Now, to address the big questions that Shaowen posted, I guess like others sitting here, a lot has been said in the last 2 days, and I feel, anything I say would be just repeating. Maybe I look at it from a different angle, just to help inspire some discussion. So one thing I was thinking, really cyber infrastructure is not just hardware, it's not just algorithm, it's also people. So all of that should met well together. What I can see is there's so much expertise and a lot of people doing research. Is there a way to serve the broader community and even the expert community, like geodesign, like other applications areas? Is there a way to harness all that knowledge and expertise to offer to the wider community? So that's one area I thought maybe we should look at it from a service perspective. I know that there are cultural issues, whether faculties get credit for doing stuff like that, so that's an issue for us to think about. The second one is, the term service computing, and now it's very often mentioned. Computing is no longer a privilege. It becomes some people say human rights. Everybody has right to compute. So, and a lot of technologies have made it so much easier to do. Cloud computing, Amazon, as long as you have a credit card, you can compute. So it's, you can't get more democratic than that. So I was thinking, as geospatial data and tools becomes more and more prevalent in every aspect of people's life, maybe that would also become more service-oriented, not APIs, but really end-to-end stuff that just, it's part of your life when you surf internet, and it's in there when you surf maps. You don't have to call special tools. It's just there. It's part of a data content or publications, and all of those should be linked together. So I think to be able to do that in a very user-friendly way, it is very challenging, and it probably needs to have a pretty fundamentally different approach to integrate all that capabilities into the systems that we use every day. I'll just stop here. I can say more, but I'll let others to have some time.
Thanks, Carol.
Okay, I'm going to jump to the questions directly. I think perhaps I talked here yesterday, and you have some context for where I'm coming from with some of this in terms of USGS needs and requirements for CyberGIS. So the first question was, what are the most important research directions? And I could give you a laundry list, and I'm going to give you a very short one. And they're not in any priority order. I think all these things are important. And they really are problems that have surfaced in the last several years in our attempts to use CyberGIS with geospatial data. The first one I'll talk about, I mentioned yesterday, is parallel input-output systems. And we saw a short presentation earlier about parallel I/O with TIFF, which we've also developed under the CyberGIS project as parallel I/O with TIFF. But expand that out to where we need to go. If you look at a standard image processing or GIS package that handles raster data, they probably handle 40 or 50 formats. Do we need to do all of those in parallel? Probably not, but we certainly need more than a TIFF writer. There are lots of different data formats out there that we need to bring into CyberGIS to be able to process them. And I don't think we can do it unless we have parallel I/O routines. When you're talking about hundreds of gigabytes of data, terabytes, which is some of the data sets that we are actually looking at and trying to put together right now, then there's no way that you can put that into a computer system with a sequential I/O and expect any kind of real-time processing to happen. So parallel input-output is, to me, a very key research area in CyberGIS. That kind of goes along with expanding the applications to big spatial data, all different kinds of spatial data. So there are all kinds of applications out there that we have not even thought about. There are very few that we've actually touched on, and if we look at what's been implemented in CyberGIS, there is a small cadre of routines, and it's a good starting point. But we have lots of other things. So can we populate CyberGIS with a lot of the traditional GIS functionality? Do we need to? Can we make ties to traditional GIS with CyberGIS? So I think that's a research area as well, is how do we do this? And I mentioned yesterday, too, the idea of commercial GIS working in parallel. And we are starting to try to do some of that with some of the commercial vendors, and hopefully we'll get there in the future. So some of that functionality will come across as those things are developed. And I think maybe A-Xing was talking about it, but I'll kind of reiterate this. User interface of CyberGIS to lower the barriers to entry. To me, this is a real key point to expanding the technology and having lots of users embrace it. In fact, people should never even know they're using CyberGIS. If we could actually make it that way, where things just happen, and CyberGIS is in the background, then that's all the better, because then that really lowers the barrier for anybody to be able to come in and use the technology. And then the last one of the important research directions I'll mention is something that has not been mentioned here, at least in the context that I will talk about it, and that is semantic data processing. For example, processing data on CyberGIS that's in resource description framework form, the RDF format. I say this because we're in the process of trying to build systems that put all of our data, or at least make it possible for users to convert any section of our data to RDF and be able to do semantic processing with it. I'll give you a simple example, a very small watershed. If we convert those data to RDF, it winds up being billions of triples. And then if we start expanding that to full-size watersheds or even state-size areas or things like that, then you're talking trillions and trillions of triples that you have to process for the semantic data. That's a CyberGIS problem. So I think semantic data processing in the context of the semantic web, if we can bring that to, bring CyberGIS processing to actually work in that environment, then that'll be a real major research accomplishment. So that's what I see as the important research directions. The follow-on question to that was some significant challenges and opportunities of those directions. And I'll just give one challenge and one opportunity. One challenge is the breadth of data types and models to handle in parallel. And I mentioned all the different formats of raster data that are out there and available. So that's one challenge, is how do we handle all of those kinds of things. And then the opportunity that goes along with that is it'll greatly expand the application areas of CyberGIS. I think there are tremendous opportunities here if we can accomplish some of these major research challenges. So I'll stop with that.
Excellent. Your step.
So I'm sorry, I didn't get the questions, but I have been thinking about the topic of the panel all day, so I had a somewhat different way of thinking about it, but I think it maps pretty well to the questions.
Excellent.
And so I started by thinking, what have we achieved to date? What has the CyberGIS project achieved up till now? And a couple of things really stood out to me in thinking about that. One was that I think the project has been extremely successful at achieving collaboration between geography, GIS science, and computer science. And this is really unusual. It's something that we always tend to shelter in our disciplinary holes. And this project, I think, has overcome many of those negatives. I think also it's done a tremendous job in exploiting extreme computation. In the history of GIS science, we go back three decades now, there have been repeated attempts to find some use for extreme computation in GIS science. And finally that's arrived. We finally reached the day where our domain produces problems that really need extreme computation. So I think those are some of the things I'd single out as achievements. What do we know about the future? I think we can predict one thing about the future very clearly, and that's that new technologies will continue to arrive, and some of the existing technologies will become obsolete. We have a very dynamic technological environment, and that's going to continue. And that points me to something that the first of the topics that fall under the category of what has yet to be achieved, and that is a stable platform, because the two are in conflict. We've got a constantly changing technological environment, and yet if we really want CyberGIS to be useful to a broader community, it's got to be stable. And that in itself is a paradox, and that's something we have to work on. I think it's particularly important because A-Xing already talked about the expert versus the general public. I think our research community, our user community, is the research community. It's across all domains of the research community, and that's a community that has very little patience with technologies that are difficult to use. They're not going to bother to learn a new technology unless it has obvious reward for them that outweighs the benefit, that outweighs the costs of learning about it. So simplicity and ease of use, not necessarily for the general public, but for the research community itself, I think is tremendously important. We can talk about education and various kinds of initiatives, and we're going to do that tomorrow as ways of overcoming that. The second issue, and there are four of these, the second is that one of the ways of defining the difference between data and information is that information is data that is fit for use. And many, many times in this project, I've heard examples where people have taken data at face value, not being concerned about data quality, about sampling, whether the data's had adequate metadata, whether there's quality control, whether it's been manipulated, reprojected, resampled in ways that potentially modify it and make it less useful. All sorts of ways in which we really have not looked into the data that we're working with. And I think David Tulloch made a comment earlier in his presentation, which I thought was very apposite. He talked about a data set which people knew not to trust. And that's a phrase that we haven't really got our heads around in this context. We haven't asked ourselves, can we really trust the data? And if we can't trust it, and a lot of data really can't be trusted, what are we going to do about it? What are we going to do about quality control? And so we heard some very nice presentation this morning about dealing with uncertainty. There used to be an acronym, and I haven't heard it in years, GIGO, which stood for garbage in, garbage out. I haven't heard it for a long time, and I suspect it's because we've got too used to just trusting the data. And what we have with CyberGIS potentially then is a technology for producing rubbish faster and in larger quantity than ever before. We have to be very careful about this because it will come back to haunt us. It's an Achilles heel which will always be there. The third topic is concerned with how we test our technologies. How do we get excited about some new technology? We develop some new method. What's our first test of whether it's good or not? Our first test almost always, is whether it tells us what we already knew. So we developed some way of mapping taxi flows in London or whatever, and because it tells us what we felt we knew anyway, it must be good. That's a very crude test. It may be useful because it does it faster, it may do it with greater spatial resolution or whatever, but still it's a very weak test. The stronger test is whether it tells us something we didn't already know. And I was reminded in that context of a comment I heard Stu Fotheringham make a couple of weeks ago in Scotland. We'd been listening to a whole day of presentations about stuff extracted from social media. And his comment at the end of the day was, when are you going to tell me something I didn't already know? Because each of these projects had basically relied on test number one. It told us what we already knew, not test number two. I think, particularly in the context of today, and this is my fourth point, the last point, we're talking about today about geodesign, or about intervention, as well as about science. And there, I think, a very important question will be, did CyberGIS help us to improve the world? It may have produced new discoveries, it may have advanced science, but did it also help us to improve the world? And I think we should be applying that test as well as the earlier test because of this context of geodesign.
Well, thanks very much for the rich set of insights. I thought was very insightful across the board. Much appreciated. As I promised, we'll open the floor immediately. I think there are a lot of thoughts. Many of them are provocative. I'm sure you will have some reactions and perhaps questions as well. We'll pass this around, get to you as quickly as possible. So raise up your hands and then I'll develop a queue.
Yeah, thank you for all the comments. But my questions really reflect to what we have heard this afternoon. When David said, give an example of the bridge, and then think that the bridge is now out of the context and have to be rebuilt. How can CyberGIS design help us to prevent something like this happening again?
First step. All right, Tapani.
Well, my interpretation of the situation is that actually, to make it simple, that the desktop computing of GIS is the old bridge, but CyberGIS is a new bridge because it fits to our context.
Can I try?
Go ahead.
Yeah. I think arguably one way of answering the question is that it's not the design which is a failure, it's the failure to maintain the design. It's the lack of maintenance over the period of the history of the bridge which is its failure, not the original design of the bridge. But I think we can go a bit further and say that in a world of CyberGIS, we have the kind of data, we have the computing power to do a much better job of evaluating the project against a broader context. And perhaps at the time, it allowed people to get from Newark to Manhattan, the Holland Tunnel, faster. Today, we would look at its much, much broader impact on the entire transportation system of northern New Jersey and New York. And so with greater computing power and better data, finer spatial resolution, we can do a better job of designing the bridge and evaluating its impacts.
To echo with that, which I think a point made earlier by Mike, that is, can CyberGIS challenge CyberGIS to come up with understanding or new knowledge for this design, or even unintended consequences or intended consequences, which may not be available without the support or enablement of CyberGIS. I think with the data and CyberGIS, that starts to become possible.
I guess I'd like to offer something too. I wonder if it's the wrong question to ask, because to really suggest that we're going to build a bridge that won't wear out isn't really real, right? I mean, you'd have to deny the iPhone as a technological advance if you wanted to stay with the technology we had before. So I wonder if it would be better posed if we really aggressively want to make technology that becomes obsolete again and makes a, get that built more into our mindset rather than saying, oh, I want to build something more stable for longer term. I want to build something transformational quickly to allow us to jump to the next thing, to the next norm.
I want to probably add a little bit to that. I do not know if some of the faulty design will ever be avoided. Doesn't matter what kind of technology you have. So probably maybe a better, but may not be what's called infinity better. So because things changes, and put a bright side is that's why science is needed. That's why scientists are there. That's probably it is. So more philosophical in that way. So we can do better, but we ever going to be avoiding all the problems? I doubt that very much. But
it's New Jersey.
Tapani mentioned this issue about infrastructures being so complex. I'm not sure that, does anyone know whether or not there was any plan about maintenance? I mean, interstate highway system, for example, you build it and it's there. So it's there for 50 years, but now it's crumbling and it's costing us a lot more. So Mike, you mentioned this morning the idea of sustainable design. That's a phrase that some people have been using, but we know very little about what is sustainable design. So there's this issue of sustainability. NSF has this issue where all projects these days are supposed to be sustainable. I mean, the whole data management plan stuff and all reusable kind of, but what is this? So that's incremental intervention. There is a time to intervene when in fact it should be changed. So the iPhone should be upgraded, but yet the question would be, what do you do with the old iPhone? So what is happening to all of the iPhones, that iPhone 5, 4, and so on, that are, they're just going in drawers. There's no plan for the nature of the recycling. So we need to be a bit more conscious here about how to take what it is we're creating and reuse what it is we don't need, or what it is we do need out of that, and maybe it's the idea of improved design, but then reuse what it is we're not using from whenever it is we cast off. And the New Jersey bridge, that's a hard thing to cast off, a 3-mile bridge, I mean. But there's iron in there, big iron. Maybe put it into a supercomputer, big iron.
Can I just add a comment, just pretty quick? I was hoping that the responses will, along the maintenance side, the GIS design, geodesign and CyberGIS really promote the long-term, constantly monitoring and designing and reconsideration. So it's not a one-step process. We finish the design, it's done. It's a continuing process, a continuing monitoring, continuing taking ideas from perspective from all different stakeholders.
And that raises the whole question of how to design against an uncertain future. We don't know what the world is going to be like in 50 years, so how can we possibly design a bridge for it? All we can do, perhaps, is to design a bridge that's adaptable against future changes in conditions.
I wanted to make sure that one thing that kind of came up and we discussed about actually building an infrastructure that is designed for geocomputation and CyberGIS. I didn't hear anybody mention that should be a research topic for the community, that, what does that computer look like? Or is it not worth chasing? Well, I didn't hear anybody say that, but I'm trying to make sure that that was either, you didn't mean to skip it, or it's not really an important topic for the community to pursue.
Oh.
Are you posing a question for the panelists? I guess that's my question. If you do, do you mind to cast it in a way that the panelists could directly respond with answers? Or you're asking me that question?
Well, I'm asking everybody that question, and I know your answer, but I wanted to know the other people's answer.
I'll give it a try. I guess I have two thoughts. One is directly to your question. It was actually on my list of issues that I was wondering. I didn't hear this out of this conference. What makes it special? What makes geospatial processing special? That is it so special that you need a different computer architecture? Anything fundamentally different from what we're supporting right now, or what people are working on in terms of parallel processing, GPUs, and the new accelerators? I didn't hear that, so that in my mind that was a question I was going to ask. Is it something that the project or the community need to figure out and perhaps better articulate that? The other question that I seem to get from some of the discussions here is that do we need a sustainable or persistent infrastructure just for the geoscience community? On the HPC side for scientific simulations and modeling, there is the Exceed, and that's shaping up to be a production quality infrastructure, which means that it's there 24/7. If you have a problem, your questions get answered right away. So there's a whole process and people backing this up. And in order to do that, it's very expensive. And so does this community need something similar? I don't mean the pile of hardware, but it's more of this whole integration of people, knowledge, and methods, software, everything encompassed in this infrastructure.
Okay, so about, do we really need a special hardware for high performance computing for GIS? I think I have the opposite view, that we shouldn't try to build, or we shouldn't even ask for special systems, because then our approach would be less sustainable. If we can use the mainstream systems, it's much easier, except in one aspect that we were speaking in my presentation and also in another one, that we want to have this quick response, interactive, high performance computing. That is something that's not, at least in Finland, in a Finnish supercomputing center, that is not available in the systems. But the people at the computing center has told already that actually it's only a kind of resource allocation issue. It can be managed by the current virtualization techniques already without really investing anything on the hardware, just a little bit on the software.
Can I respond to that?
But to ask that, why should we ask for special hardware? In the 70s, late 70s, we still had image processing systems which had special boards and that kind of things. I'm really happy that we got rid of that time, that we can use a just normal workstation and that kind of things. It's much cheaper and so on.
I would like to say actually the special machine has arrived. Actually, in the old days, we do single core sequential processing. And like Geographer has been very creative to change the geographical process, which is 2-dimensional, 3-dimensional, into 1-dimensional processing. We're being very creative because of the limitation of hardware. Nowadays, we have hardware that allow parallel processing. Let me give an example, geographical process. Say that watershed modeling, we simulating the flow, raindrops coming down the ground, and then trickling down the slope. That process actually contains sequential and parallel. For example, two watersheds independent of each other. Actually, the flow routing is independent. And even cells on the same level, their routing is also independent. So nowadays, we can take that and put into the computer and allow that parallel to happen. Not alone that, in addition, we allow the communication with the pixels, cell, the geographical process, to be simulated in the computer because we have shared memory, we have an MPI communication, allow this thing to communicate. So the way I see is I do not know if we need to add special machine because the special machine has arrived with the high performance computing facility. So now we're able to go back, take our sequential process to be a parallel process that as much similar to the natural process as possible. So that's, from that perspective, the future looks much better than what most people think it is. So I think we now much more free, don't have to convert 1 dimension. We can actually do 2 dimension, 3 dimension, even probably 4 dimension. So, thank you.
Can I jump in? So I agree, yes, we need dedicated hardware. I don't think it's ever going to happen because of the scale issue. So we were actually just talking about this right before the session. You know, like NVIDIA, right? The graphics processing unit and CUDA is their fastest growing unit, but it's still about this much of their market share. And we were talking about this just outside of the table because there are so many more high school gamers out there in the world compared to the people in this room that it just pales in comparison in terms of their market share. Now it's growing, and because people in this room have deeper pockets than the high schoolers do. But you still have a scale problem. That being said, dedicated hardware would be wonderful because I do think the data and its structure is one of the unique challenges for the computation itself. But going back to actually Carol's thing, I agree 100% with Exceed. The problem with this Exceed is it's a moving target. Right? So everybody here wants fast, 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 interactive. We want to be under 10 seconds with Robert and everything else. And that means that you have to customize the code to the machine. The machines then go out of date. So when Amy was here, she showed all of those Exceed systems that are going out of sync. So trestles, we have, CyberGIS has multiple methods on trestles. It's going, I think it was extended for another year or two or something. Yeah, but that's going out of sync. So all of that code has to migrate to a new architecture. It has to be recoded, re-optimized in order to get that speed that you originally had, right? So I think that would be wonderful, but I think that it would also become outdated in, a year, 18 months, and then you have to build a new system potentially. Yeah, I mean, Anton, right, was made from molecular dynamics, is a perfect example, but I don't think any of us have as deep a pockets as that guy. So Anton was made from molecular dynamics. It was basically code and hardware made by a guy who was in high-speed trading, made a lot of money there. But anyway, that's off topic, so.
I still want to comment this one more time because I'm so old that I studied AI in the mid-80s, and that was a time when there were special computers for AI, for symbolic processing. Those were promised to be a big thing, but they all died out because we got so powerful general-purpose computers, silicon graphics, whatever. And I just don't want that we repeat that failure. The mainstream way of thinking is so powerful that we should believe on that.
I have a question related to your last two questions on the screen, which is that this exciting panel discussion really inspiring, but I'm looking for a keyword that hasn't been mentioned yet, and I wonder what is the relationship in terms of CyberGIS with OGC, with the Open Geospatial, the Standards Committee. Because I think that in order to facilitate collaboration and talking about related communities organizing together, not only within the geospatial domain, but also connecting out to the general, the mainstream, quote unquote, cyber infrastructure technologies. It seems like standard is a must. And how do we, I'd like to hear from the panelists on our strategy to, for one, shape the standards establishment and also to contribute to it. Thanks.
Maybe I could update and then I'll pass to the honor panelists for their more futuristic thoughts. So the status of the project, as you might have heard from the updates on the first day, we very much encourage adoption of existing standards coming out of OGC or even other related consortiums. And we also encourage in the project, we do have plans. For instance, you might have heard of the work from the ASU group. They were researching spatial weights and provenance structure. And ASU group is well positioned to interact with OGC. We would have liked to move that faster, but they are now better prepared perhaps to move forward, is to contextualize that progress in the OGC context, see whether the ontologies and the metadata has any uniqueness contributing to the OGC community. Another area in the CyberGIS project is analytics, which is related to WPS, which right now is not deemed as a very successful standard in the general OGC context. We think what we have done, especially in the distributed computing framework of CyberGIS, really could help move the WPS, the web processing standard, to the next level. There are initial discussions in that regard, but again, to push a standard into existence, that is pretty effort-consuming, which we need to be cautious about in this NSF project because we are primarily research-driven. So it's a dynamic area. We are very carefully assessing when and how much we need to contribute to that regard. But the standards interfaces are important pieces of CyberGIS because it's tightly connected to the integration challenge and opportunities we were discussing earlier in the conference. So that's the status. I think the panelists might have some insights as to what will be related to this question or comment, maybe with more futuristic thinking.
I think it's a very tricky issue because as a research project, we are necessarily pushing forward on the boundaries. And ideally, I think that standardization should follow research. Once the research has been worked out and we know the best ways of doing things, then's the time to standardize. And I think there are some examples, and the one I'd cite is the standardization of data quality description, which goes back now to the 1980s in the five-fold way, and got embedded in the metadata standard in the early 90s. And unfortunately, that was done before a lot of the research on geospatial data quality was done. And the problem is that one can't really go back and revise a standard based on new research because the standard itself creates momentum. It does tend to fix things. And I think, I would argue strongly that we should go back and revise the metadata standard with respect to data quality. But that's an uphill fight because there's such an investment in the existing metadata standard. So I think it is a tricky issue.
Shaowen, what did you want to do with time?
We have 5 more minutes.
Okay.
In this. Go ahead.
Just a quick comment. We use as many standards as possible.
I'll respond to Budu's question earlier or comment earlier about hardware and architecture. And, we had this discussion offline with Budu. But I do want to comment on this because I think this is an opportunity. This community is well positioned to contribute to the evolution of novel architecture. CyberGIS has this critical aspect tied to integration with both data, compute, and visualization intensive tied together. And in the architecture of computing environments, this has now also become something very important. How do you handle complex workflows using the community language coming from A-Xing or supercomputing? Because as you saw from Amy's slide, she was showing there's this push in the scientific paradigm to link the simulation model-based framework with the data-driven framework. In the GI science community, we've been doing this, but we're not doing this in a scalable way to complex infrastructure like cyber infrastructure. But the problems we bring to the table are very representative, demanding this integration in a holistic fashion, in a fashion to deal with complex workflows, but also with a desirable response time. And this is essentially lots of geo-design scenarios you heard from this conference could bring to the evolution of novel architecture for the future. I think our community voice is getting heard, at least for instance, some discussions at NCSA, and we hope this message gets better debated and further voiced. But to me, based on what I have learned, that's a tremendous opportunity. This is integration, GPU, cloud, data-driven systems, compute intensive, traditionally high-performance computing systems. And we need them all, and we need them to be integrated in a very novel fashion, holistically, to handle the complex workflows we've been familiar with in the past for a long time in GIS, but the workflows is getting more interesting into the data-intensive world. I hope that satisfies your appetite to some degree. And now we have maybe a little bit of time to ask panelists to see if there are any closing remarks. And who want to take the first step?
Yesterday, I think Shaowen posted the question in one of the panels. The title was Beyond Software Integration. Now, I would argue that software integration is never ending. It's an ongoing thing. New technologies come out, and because of all the research people are doing, and you want the best and latest. That's always the trend. So I think integration is just going to have to be going continuously. And what I like to see is more collaboration between projects, because it's pretty obvious everybody has their favorite ways of doing things and creating their with their creativity, coming up with their own algorithms and all that. And all of that is very good, except that it's really, really hard to make these things play together. And so I think that's probably, software-wise, I think that's the single most challenging task that we have to tackle.
I would say, to be futuristic, to say that with the CyberGIS, hope someday we're going to do the AAA. AAA stands for anybody, anywhere, anytime you can do geographic computing. That's probably the promise, I hope that's the promise of CyberGIS, AAA.
I have perhaps a detailed comment that we have been speaking about quite a lot of open source software, many of us, even we release our software as open source. But it's not really very productive in the sense that we just release them, and the user community for many of these packages are actually very tiny. They don't have the community to build them. So my kind of dream is that we would have a new platform, CyberGIS or something, on the top of which we could build our work.
Maybe I could say something about question 4, about collaborations and partnerships. Because I think that one thing that has been missing today, and I apologize I wasn't here yesterday, so I don't know. But one thing that's missing today is the presence of the domain sciences. Today's discussion has looked very much like a build it and they will come project, in which we are doing our best to build something in the anticipation that there will be people out there to use it. And I think we have to be much more aggressive. I think we have to pick our partnerships with particular domain sciences. And we were talking at lunch about how some domain sciences, because they're broader, would be more suitable because they give us leverage into a broader community. We were talking at lunch about the disaster resilience kind of community. We need to pick those partnerships, and we need to be aggressive in enlisting their support, in getting their views, because build it and they will come will only take you so far. Yeah, I apologize.
I'll address the same thing that Mike just did in terms of collaborations and partnerships, and I'll be very quick with it, and that is what I've seen over the last several years indicates that collaboration and partnerships that are necessary have to be among academics, government, and industry.
Which we are proud to say CyberGIS project has them all. With that, let's thank our panelists one more time again.